Hi everyone, it's Daniel from TechMind Factory, and this is the first video from the Cloud Pharmacy video series. In this video, we will make introduction to the whole concept and we are going to discuss solution architecture. Before we jump into the architecture, I want to present the demo of the whole solution. So if you watch the trailer I published on my YouTube channel, you can forward this video to the architecture diagram. If not, I hope you will enjoy this demo. And then we are going to discuss the architecture. So let's start. I hope you enjoyed the demo. So it's time to discuss the Cloud Pharmacy solution architecture. So probably you saw the diagram I published in the GitHub source code repository. If not, I encourage you to visit the GitHub source code repository for the Cloud Pharmacy. The link is currently displayed on the screen. It's also available in this video description. So in this video, I would like to talk about Azure Cloud resources that I decided to use to implement the whole scenario of the Cloud Pharmacy. So first of all, you notice in the demo that I have three different web applications. I have patient web application, I have physical web application, and there is also Cloud Pharmacy store web application. So of course, as names indicate, patient's web app is for the patients. They can create accounts, they can sign in, and they can update their profile, they can schedule visit with physician, and they can access their prescriptions. And on the other side, they can use the same account to sign in to the Cloud Pharmacy store, a web application, where patients can see the available medicaments, they can buy those medicaments, but they can also obtain discount after presenting patient's verifiable credential. And of course, there is also physical web app. And this web app is dedicated for physicians. They can sign in, they can create their profiles, they can fill out their schedules, and of course, they can create prescriptions for patients. A small disclaimer before we move forward. I know that not everything is implemented in the solution, like generating prescription or canceling visits and other functionalities. Believe me that I did my best to implement this solution. I put a lot of effort and time to connect the dots and to make something functional. So, of course, on one side, I decided to complete the solution, to finish the implementation, and to show the ready solution. And on the other side, of course, there can be improvements applied. So if you will see anything what can be done better in the source code, or if you will find out that some scenarios can be implemented in a different way, you can either just pull this source code from GitHub and build your own solutions on top of my code, or you can just create pull request to merge your changes, proposed changes. So definitely I will review those pull requests. Okay, perfect. So when it comes to those web apps I decided to use Azure Web Apps, so Azure Web Apps Service with App Service Plan. So it's perfect solution available in the Azure Cloud to host web applications. Of course, Azure Web Apps and App Service Plans provided the way to scale. So in this case, we can scale in, scale out. We can add more resources, more power. If there will be a higher load for one of the applications, they can scale. So that is why you will also notice that each web application was created with dedicated app service plan to handle this auto-scaling mechanism independently among those different apps. Then I decided to use Azure Container Apps service in the Azure Cloud to host web APIs in this solution. And before we jump into the Azure Container Apps, again, just like a small disclaimer or answer to the possible question that can be asked, why not Azure Web Apps? Why not Azure Kubernetes Service? Why not Function Apps? Of course, you could use those resources available in the Azure Cloud to implement this solution. So Azure Container Apps resource is not the only one that should be used here, and this is not the best choice to be done. You can use those other services. But I personally decided to use Azure Container Apps, first of all, to learn more about this great service, but also I wanted to discover what is behind it, because in the past I worked a lot with Kubernetes and Azure Kubernetes Service, and I found out that there is a lot of configuration stuff before we can just launch our application, just deploy it, launch it, and use it. So I found that Azure Container Apps, this new service available in the Azure Cloud, is perfect match because I can run my APIs in the Docker containers without worrying about the underlying infrastructure in this case. So I use Azure Container Apps, so Patient API, Physical API, Pharmacy Store API, and Verifiable Credentials API. Those APIs are hosted in the Azure Container Apps using Docker containers. And of course, there will be dedicated video in this series about Azure Container Apps, but I want you to know that Azure Container Apps is this new service available in the Azure Cloud. I'm saying new because it was released a few months before this video was released, and it's great choice when you want to still use some concepts from the Kubernetes world, I would say, But of course, you don't want to worry about the configuration, about the underlying infrastructure, and in general, you don't want to fight with the service before you can use it to host your applications. And of course, I mentioned Docker, so I need to keep those Docker images somewhere. So I decided to use Azure Container Registry, which is the private registry available in the Azure cloud. This registry can be used to store all the Docker images securely. There are some other cool features in the container registry which can be helpful, but in general, I just wanted to use this container registry to version my APIs, to keep those Docker images there, and to make it possible for Azure Container Apps to pull those images and start Docker containers. When it comes to data, I decided to use Azure Cosmos DB. And again, you can ask, okay, Daniel, but why didn't you use Azure SQL? Of course, Azure SQL database could be also the perfect match for this solution. I decided to use Azure Cosmos DB again to learn more about this service, to check some functionalities of this service. I wanted to use globally distributed database, and in this case, I do not have a relational database used in this solution. So of course, in the Azure Cosmos DB, I have JSON documents with the data about patients, about physicians, about medicaments, and other things used in this solution. And of course, Azure Cosmos DB provides some other cool features like geo-replication and change feed. So I decided that, okay, I want to use this in my solution and learn more about this service. But of course, you could also use Azure SQL database. Now, when it comes to storing images like photos of physicians or storing pictures of medicaments, I use Azure Blob storage. So in this case, all those pictures are stored in this Azure storage account in different containers. And this is the perfect match when you have unstructured data, like you have text files, PDF files, images, videos, any other kinds of files. Storage account, Blob storage account here is a perfect match. So I use it. When it comes to patients' credentials, I decided to use verifiable credentials service, and to be more precise, Azure AD verifiable credentials. So with this new service available in the Azure cloud and with this quite new technology, I can issue verifiable credentials to patients. Those credentials can be stored in the Authenticator app, Microsoft Authenticator app. And once the patient has this verifiable credential, patient can sign in to the Cloud Pharmacy store, can present this verifiable credential, and this patient can obtain discount for specific medicament. Of course, there will be dedicated video about verifiable credentials and how it is used, how this service is used in this solution, but I just want you to know that something what you saw in the trailer, in the demo, where I'm scanning the QR code and then I have my Authenticator app on my mobile phone, and here is the patient verifiable credential. This is something what is connected with Azure AD verifiable credential service. Then, when it comes to notifications for the web apps, I decided to use Azure Function app connected with Azure Sign Alert service. So in this case, when the patient scans the QR code and the verifiable credentials is being generated, verifiable credential service sends the notifications. So we have confirmation, for instance, once the patient scanned the QR code or once the verifiable credentials was successfully issued to the patient Authenticator app and so on. So in this case, I want to be sure that I can display those real-time live notifications in the web apps. So that is why Patient web app and Cloud Pharmacy Store web app, those are connected to Azure Sign Alert service. And once for instance, the the new verifiable credential is issued to the patient, we can display this green notification in the web application. Because verifiable credentials API will publish event to the function app. This function app will send notification through the Azure Signaler service, and web application will be notified nearly in real time, I would say. So that is why I use Azure Signaler service. Then when it comes to securing access to the patient's web app and Cloud Pharmacy Store web app, I use Azure AD B2C. So the identity service available in the Azure Cloud, that is the perfect match where you have scenarios where you want your users to be able to create accounts, to register, to sign in, to reset their passwords on their own. So in this case, I use Azure AD B2C for patient web app and Cloud Pharmacy Store web app. And for the physicians web app, I decided to use Azure Active Directory. So in this case, when it comes to physicians, they cannot create their own accounts. The administrator of the Cloud Pharmacy solution is responsible for creating account for physician, and then this specific physician, this doctor, can access the physician's web application. And of course, we are going to talk about differences between those two services, Azure AD and Azure AD B2C, and how they were used in the Cloud Pharmacy solution in details. Now, when it comes to storing secrets, connection strings, and all the parameters that should be securely stored, I decided to use Azure Key Vault. So there I keep all the client secrets, connection strings, keys, and so on. And of course, I use Azure Monitor together with Azure Application Insights to just monitor what is happening with my solution when it comes to the infrastructure and when it comes to the application's source code. Perfect. So right now, it's time to jump to the GitHub and see what is happening in the Cloud Pharmacy source code repository. So let's do it right now. Here is the Cloud Pharmacy on Azure source code repository on my GitHub. Again, the link is displayed currently on the screen, and you can also find the link to this source code repository in this video description. So once you open this repository, you will notice that there is a README file, of course, with solution architecture, with screenshots from patient web app, from the pharmacy store web app, and from the physician web application. And you can also see that here we have patient's verifiable credentials. So this is the credential that is visible in the Microsoft Authenticator app. So now if we scroll up, you can see that there are some folders in this source code repository. So let me start with GitHub Action Workflows. So in the Workflows folder, you can see that there are YAML files, and those YAML files are used to build the Azure infrastructure. So those different actions are responsible, of course, for creating different Azure resources like Key Vault, like container apps, like Azure Web Apps. But also those actions, those workflows are responsible for deploying applications to those Azure resources. So in this case, we can, for instance, talk about a patient web app, physician web app, and Cloud Pharmacy Store web application. Those apps are deployed automatically to Azure Web Apps using GitHub Actions. So here you can see that there are different YAML files responsible for building and deploying Pharmacy Store web app, physician web app, and patient web app. But of course, there are some other workflows to deploy notifications, Azure Function app, or to build the Azure infrastructure. So I encourage you to go through the workflows files available in this source code repository. We will, of course, discuss their usage in the next videos in this series, but I want you to understand that this is the place where those automation scripts are kept. If we get back to the root of this repository and open source folder, you can see that there are four folders: Azure Infrastructure, Backend APIs, Verifiable Credentials Assets folder, and Web Apps folder. Inside Azure Infrastructure folder, you will find Azure Bicep templates. So those templates are used to create Azure resources. So to create Azure resource group, to create Azure resources inside this resource group. So those Bicep files are used to implement infrastructure as a code approach. So I don't want to create each resource manually in the Azure portal. I have those Bicep files here, and those Bicep files are referenced in the GitHub Actions workflows I mentioned before, and I can automatically create all the resources without using Azure portal. So here, again, during some next videos, we will jump to those files here, but I just want you to understand that resources in the Azure cloud can be created using those Bicep files. So you will find out that here is container registry, for instance, Bicep file to create Azure Container Registry. There is also Bicep file responsible for creating Azure Container App environment, Container App apps, and some other resources. So this is the Azure Infrastructure place. When we get back to the source folder here, the next folder is called Backend APIs. And this is the place where the source code of Backend APIs is kept. I developed those APIs using .NET 6. So those APIs were developed with .NET 6. And you will find out that here is the Patient API, Pharmacy Store API, Physician API, and Verifiable Credentials API. But also I decided to keep live notifications function app in the same folder. So you will find out that the source code of this function app I mentioned before is also kept in the Backend APIs folder. If I get back to the source folder, in the Verifiable Credentials Assets folder, there are two JSON files. Those JSON files are used by Azure AD Verifiable Credentials service to make it possible to display those verifiable credentials in the Microsoft Authenticator app. I will discuss it in details, but please keep in mind that without those two JSON files, you will not be able to use Azure AD Verifiable Credentials. And the last folder, called Web Apps, is the folder where source code for free web applications is stored. So for the Patient web app, Pharmacy Store app, web app, and Physician web app. Those applications were developed with .NET 6 Blazor server technology. So in this case, as you can see, everything was written with .NET C# and .NET Stack. Like we have the consistent stack in this Cloud Pharmacy solution. Perfect. So one more thing, let's jump to the Azure portal to see the resources that were created with those Bicep files I mentioned before. This is the resource group that I created to create all the required Azure resources for the Cloud Pharmacy solution. So as you can see, the container registry is here. Azure Web Apps are there. So there is a dedicated web application created for each app. So we have a Patient web app, we have Physician web app, and Cloud Pharmacy Store web application. There is also Application Insights resource created to monitor what is happening in the application source code to detect issues, errors. There is Azure Cosmos DB, so the database I mentioned before to keep the patients and physicians data and medicaments data. There is Azure Container Apps environment created. So this environment is used to host container apps like Patient, Verifiable Credentials, and others. I will discuss it in one of the videos in the nearest future in this series. There is also Notifications function app created, Azure Key Vault to keep all the secrets If we scroll down, you will also notice that there is Log Analytics workspace to monitor what is happening with containers hosted in the Azure Container Apps. And here we have those free container apps to host APIs like Patient API, Pharmacy Store API, and Physician API. So those are the container apps. You can also see that I have 4 dedicated service plans. 3 of them are app service plans for the web applications. So each web app, like Patient web app, Physician web app, and Cloud Pharmacy Store web app, those have their dedicated app service plans, because I want to be sure that I can scale them independently. And there is also a consumption plan created for the function app. And if I scroll down, you can see that I have SignAlert service created here for those live notifications about verifiable credentials. There is also Azure storage account created to keep all the pictures of the medicaments and profile photos of physicians. There is dedicated storage account for the function app, because when you create Azure function, storage account is required. And also there is verifiable credentials API, which is also hosted in the container app in the Azure cloud. So that's basically it when it comes to the overview of Cloud Pharmacy solution and architecture and components. I hope you enjoyed this video. And in the next videos in this series, we are going to dive into different parts of this solution. So thank you so much for watching. If you do not subscribe my channel, please subscribe, because in the nearest future, I will definitely publish more videos. Thank you.